We can now take a little closer look at the origins of a group of primates known as prosimians. So you can see just to remind you of the cladogram of primates, but here you see on the left a circle of lemurs, lorises, and galagos. You may remember from the primate lecture. These are things like lemurs, which we do see on TV fairly frequently. That happens to be a ringtail lemur on the lower right. And their origins were somewhere back around 50 million years ago, although there is a suggestion on molecular evidence where they've looked at similarities and differences in genetics, mainly between lemurs and monkeys and so on and so forth, that suggests that it might be as much as 60 million years ago, but I think that's too old. The oldest fossils that we can recognize in this group, I think, take us back to about 50 million years ago. They are found in various places. Probably one of the most convincing examples is from Africa, Azebius, as you see, and these are only fragments of jaws and teeth and a little bit of jaw and so on. There's not a lot to go on, but there are telltale clues in those teeth that tie them to prosimians. Well, what about anthropoid origins? And remember how nice it is now that you know something about the Linnaean hierarchy. And when we say anthropoid origins, we mean New World monkeys, Old World monkeys, apes, and humans. That is, as a group, are called anthropoids, as opposed to the prosimians, which are lemurs, lorises, and galagos. Now, we think that this most likely happened sometime during the Oligocene, between 23 and 34 million years ago. It is undecided whether or not the arena in which anthropoids first appeared was in Africa or in Asia. And you'll see why there's a conflict. In Africa, there are early anthropoids, primate fossils of very modern aspect with a post-orbital bar closure that have been discovered in the Fayum of Egypt, a desert region southwest of Cairo. They've also been found in Oman, in Algeria, and they date from the Oligocene. Now, these are tiny little things. The jaws are just a few centimeters long, so they're really very small primates. The Oligocene was an interesting time. As you can see here, there is a cooling trend, and the Earth started to get a little bit cooler. Temperate zones were coming southwards and so on, but we think this is when we first see examples of higher primates. This is a picture of Elwyn Simons on the right, a colleague of mine for many, many, many years. He used to teach at Yale University. He was an extraordinary paleontologist, a real field man who went out and made extraordinary discoveries in a whole series of places, but particularly well known for his discoveries by his team in the Fayum Desert of Egypt. And you can see that's a pretty desolate area. And if you look closely, you can see some vehicles right there, and it shows you the scale, how large this place really was. Now, there is a specimen known as, appropriately, as Egyptopithecus, which means the Egyptian ape. And it is an ape that has many similarities to later apes. It has a interesting dental formula. I think we touched on that, but we can characterize our dental formula by 2 incisors, 1 canine, 2 premolars, or what your dentist calls bicuspids, and 3 molars both in the upper and lower jaw. Old World monkeys, by the way, apes and humans have that dental formula. New World monkeys have a different formula, which we'll touch on. They also had a 5-cusped lower molar, which we have. We generally reduced ours in modern humans, but apes and humans are tied together by having 5 cusps, those little bumps on your teeth, and the lower molars, only 4 in the upper, and they're arranged in a Y pattern, as you will see. And that's present in Egyptopithecus, just as it is in chimps, gorillas, orangutans, gibbons, and humans. The orbit is completely enclosed. If you'll notice here with the skull, it's a completely enclosed orbit. There's a socket there. There's an orbital socket there that allows individuals to, allows the eye to be totally enclosed. They are very frontated, so you have nice three-dimensional vision. They were probably arboreal quadrupeds, but they have something that apes and humans don't have today. And what is that? It had a tail. So somewhere that tail was lost between Egyptopithecus and us. And this dates from the Oligocene about 30 million years ago. So within this time period, the Oligocene, it appears that Egypt was really, that what we call Egypt today, was the most likely area where we see the best ancestors to later things. Perhaps even a common ancestor to the old world monkeys in Egyptopithecus, keeping its tail, but giving rise to apes like ourselves, like present-day apes and humans. Now, there is a possibility that Egypt had also some possibility as a origin area for anthropoids. This is called the dawn monkey, Eosimius, Eo meaning dawn, sinensis, which means Chinese dawn monkey, and was found in the Jiangsu province in China. And it's dated at about 42 million years in age, which is really quite old. It had a tail. It was a tiny creature, probably a very small creature, but it is a candidate because it does contain a number of features in its teeth and jaws that convince some people that this is a possible ancestor to later anthropoids. Also, more recently, there's been recovered this very fragmentary lower jaw with a couple of teeth in it. It's called megacanina, large canine, and you can see a very large canine right there, lower canine sticking up. And it's from what was called formerly Burma, today it's Myanmar, and it is about 38 million. So it's in that time period, in that Oligocene time period, that perhaps creatures that are ancestors to later anthropoids arose. Now, one of the great quandaries is how in the world did monkeys get to the New World? That is to say, South America. There are living monkeys, as you probably know, in South America as well as Mesoamerica. We don't have any in wild in North America. They're tropical animals. But in the late Oligocene of Bolivia, there are fossils, Branicella and Homunculus, two different genera, not known by a large number of specimens, but they're clearly monkeys. And they have a different dental formula. They have one extra premolar or bicuspid, so they have 2-1-3-3, 2-1, 2 incisors, 1 canine, 3 premolars, 3 molars, upper and lower on both sides. And the question is, how in the world did they get there? I don't think they're strong swimmers. I don't think they swam all that distance across the Atlantic. Were there islands that they were able to hop across? I don't think so. Were there huge vegetation mats that came out of large rivers like the Congo? We don't know. This is still an open question. How did those monkeys get all the way from Africa to the New World? Maybe something for you to figure out someday.